Hey guys, welcome to another calculus lesson. Today we're going to talk about the different types of notations that you're going to come across in calculus. Now, the first thing that we have already talked about is that when you see the notation a function of x, you can think of it as y. Right, and the reason for that is because when you see an equation, for example, y equals x squared, and you draw the little parabola for it, and what it means is that when x is equal to 1, y is equal to 1, when x is equal to 2, y is equal to 4, and so on. And you can think of this as a function because y is basically the output variable and x is the input variable. X is the input variable and y is the output variable. So you can think of y as a function of x is equal to x squared, and where a function of x, the x is the input, and basically y is equal to a function of x. So if you have been doing all of our Maths B lessons, this should make sense to you. So basically f of x is equal to y. Now if you remember, we talked about differentiating is the finding the instantaneous rate of change, or in other words the gradient function of these. Now if we say this is the original function, then the differentiated function you can think of as f dash x, or you can sometimes also see y dash, or you can sometimes also see dy over dx. So all of these notations mean the same thing. So what is dy dx? Well, you can think of dy dx, well, you know what it is because it's the gradient function. It's the differentiated function of y. But you can see where this comes from because basically the derivative of y is found by getting the limit of change in y over change in x when as change in x approaches 0. Right, which is, it means exactly the same thing as when we did the first principles derivative, when we talked about a function of x plus h minus f of x over h as the limit as h approaches 0. These two mean exactly the same thing because the change in y is the same thing as if we drew a graph and we had a curve and we had 2 points. The rise is the change in y and the run is change in x. And basically the instantaneous rate of change is when the 2 points come so close together that the change in x approaches 0. Exactly the same thing as when we talked about differentiation using first principles. So basically the point of this lesson is so that you understand that when you see y dash or when you see dy over dx, you're going to treat them the same way as f dash x. Basically, it's the differentiated function or the gradient function of the original function. And you're going to also understand that changing y is the same thing as y2 minus y1, which is also the same thing as f of x plus h minus f of x. Right? If we call the first point x and the second point here x plus h, and we call this change in x, we rename that. Actually, I'll just write it on the top. If this part was h, so basically h is the same thing as change in x. Right, so if we name the x coordinates this way, then the y coordinates will be f of x, and the second one is f function of x plus h. And so basically this tutorial sums up all the different notations you're going to see in differentiation. Okay, hopefully this has helped a little bit for you to understand the different notations in calculus. See you guys next time.